Alright, so this is a neoPLC ecosystem. So far we've got 9 boards, but we're adding more every day. So just as a brief overview, we have the microcontroller, which is based on a Cortex M4F, a very powerful fast chip with Bluetooth built into it. So without having a second board or a second module, we can immediately connect our projects to our phone and make apps. We have a battery charger, which can charge most LiPo and lithium-ion batteries, and also has a switch, so it's easy to make your project portable and just kind of connect the microcontroller to the battery charger and the battery, and it just stands alone. You can switch it on and off, things like this. We have a little OLED display which you can check out on the website. It's very nice and crisp and bright. You can see it even in sunlight. We have a few sensors, so I've kind of organized this with main control functions and sensors and inputs and output boards. So we have a few sensors. We have what we call an environmental sensor, which measures pressure, temperature, and humidity. We have a GPS, which uses a U-Blox chip. It's a very nice GPS. It can use all 4 active GNSS satellite constellations, so it's very accurate compared to some others. We have an IMU, an inertial measurement unit with 9 axes of measurement. That's 3 accelerometers, 3 gyroscopes, and 3 magnetometers, also called digital compasses. And finally, we have the input-output boards, which is nice for making Internet of Things projects for reading sensors and controlling our environment. That's what these are for. So we've got digital inputs and outputs in this board, which means this board can either read buttons or switches, or it can control things that turn on and off, like lights or maybe spinning motors on and off, or solenoids. This is the pulse width output. We also call it, it's an analog output, so we can control something like the brightness of a light or the speed of a motor by varying effectively the output power that runs through the board. And finally, we have an analog input, which measures voltages. Many sensors that we don't have a specific board for, many sensors output a voltage, and we can read those sensors with the analog input board. All right, so that's a quick overview of the boards, and so we're going to get started. Today, we're only going to be focused on the microcontroller. So get this out of our way. All right, so now when you receive your microcontroller board, it's already got some code loaded on it. So we're going to do something here that'll let you kind of see what we're getting into and do something fun and kind of check that it's working so that you know immediately that your controller is working and can communicate with the phone and everything's good to go, even though it was tested before it left our facility. So, all right, we're going to plug this in. It uses micro USB, and first time you plug this in, it should already have this code loaded, and it'll start blinking. We'll see the program at some point in one of these tutorials, but the blinking is programmed so that until we connect to our phone, it's going to sit and blink, and as soon as we are connected, it's going to stop blinking. All right, so what we'll do here is now that we see the controller's working, I'm going to get on my phone, and what I'm going to do most of these tutorials on a MacBook and an iPhone. So I'm going to record this. All right, so you can go to the App Store, and we've put our app on the store. This is an easier way to get into it because we can make sure that it works as we've designed it. This code's available on GitHub, and later on in projects we'll be modifying this so that you can do whatever you want. But go ahead and we'll get this. So I've already downloaded it, but we'll reinstall it here. So get this off the iOS App Store from your phone. Wait for that to load. We'll also be putting links to most of this in the notes below, and we will probably be making a text version of this tutorial as well. So now that we've downloaded the app, we can open it from the App Store, just like that. All right, and so here is the neoPLC framework app, which just lets you It's very simple because we want it to be simple because it's easy to modify and use as kind of a framework to build your custom application on. But it's got some critical pieces already in it. So a few things you'll see here. This is the first of 2 pages, kind of the setup page. You see we've got this nice menu that looks for neoPLC boards and lets you select them. And if you look in the top right, there's a red BLE icon. So if I select a microcontroller off of the list, it'll connect, and you'll notice 2 things just happened. That red BLE indicator is now blue, signifying that we're connected, and the microcontroller LED is no longer blinking, so that's great. That means both devices agree that they've connected. Okay, and then here we've got a simple, so we hit start. We've got a very simple interface here that is a place where you would be able to jumpstart your own code and add your own buttons and views and anything you want. And we'll do a lot more of that in future lessons, but for now we can just test the connection. So if I hit this button in the middle of the screen, I send a message to the controller to turn the light off, and it tells me that it's off. That's why it says so at the top of the screen. And every time I push the button, I'm able to toggle the state of the LED. So that's not, terrifically exciting, but it's a great way to start. We know we've got a connection, and you can go and again, you can look at this code on the GitHub, and in our examples when we get Arduino installed, and you can immediately use this as a starting point for your own project.